All right, cool. So we just finished this guy, and I want to show you how I can do this without necessarily making every single circle, but accomplishing the same goal by only really making one circle. So I'm going to, again, just make sure that this guy is set to an inch, just to double check myself since I'm starting a new thing, and it looks like I need to kind of extend it out just a little bit. All right, there we go. Cool, so now I'm at an inch wide, the radius, and I'm just gonna make one single circle. I'm gonna do it like over here on my page. So I got some space, but I'm not actually gonna need that much space for this. Cool. So here is my new circle. That's the center point of it. And just like the second circle on this one that I did, I picked a point on the outer circumference of the circle. And now I'm going to just double check that my compass hasn't changed sides. And I'm going to just make a little tick mark there. So notice I could make the entire circle just like I did before, but because I only really care about where the circles cross each other, I can just make that one mark and just go from there. So I'm gonna just keep marking where my circles would have crossed if I made the whole circle the original circle. And there we go, cool. So I've now made marks that represent each one of those marks from my original hexagon. Each one of these marks is essentially the same marks that I just made right there. So when I go ahead and I connect this, I should wind up with the exact same hexagon that I made before, with a lot less work involved. Cool. So hopefully you can recognize that this guy is exactly the same hexagon as the one inside of there, but there's a lot less compass marks kind of getting in the way of this guy. So this would be a much cleaner construction. So I'm going to take the same idea that we did here and then we did here, right? These are those crosses where all of these circles would have crossed the original circle. We're going to flip this guy over, and now we're going to create a circle that has a radius of 2. So I'm going to extend this guy out so that it is 2 wide, like this. Perfect. And I'm going to put this point right there on the grid and set up my circle. So I'm going to draw this circle. And if it's not the most perfect, it's fine, but you should be able to basically be kissing a cross point on the grid at least 4 spots, all right? So kissing or sitting straight on, this is good enough right here. All right, so I've got my circle, and I'm going to pick one of those 4 points on the outside of the circle to start. I guess I'll just go with this one, all right? And keeping my compass unmoving or rigid, as we would say in geometry, I'm going to do the same thing I just did before, where I'm going to kind of create the compass marks that I need. Now, what are you noticing? This first mark wound up going straight through a place that the circle crosses a line. That's pretty convenient. When I go from here and do another one, I'm seeing that again. So that's good confirmation that you're doing it right. I'll do this again, and look at that. We're right there on a line again. Right here, we're on a line. Right here, we're on a line. Cool. So these points right here are going to be the 6 points we need to make our new hexagon. So I'm going to just very quickly make a hexagon here. And then I'm going to ask, what is the area? How many squares can I put, unit squares, inside of this hexagon? And since each one of these unit squares is at exactly a square inch, how many square inches are inside of that hexagon right there? That's the question. So with everything I've been doing with you guys so far, I've been asking you to break down a more complex or compound shape into its component shapes, right? So if I'm looking at this guy, I might be able to see that I could make a whole bunch of triangles on this. So let's go ahead and form as many triangles as we can out of this hexagon. And what we're gonna notice is that each one of these triangles is an equilateral triangle. So setting this guy up here, bam, 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 each side is exactly the same. So now I have 1, 2, 3, 4, 5, 6 congruent triangles. And if I can find the area of one of them, I can then figure out what the area of the whole shape is. So if I want to do that, I need to figure out what the height of the triangle is. So again, if I want to solve for the area of a triangle, the area of a triangle is going to be equal to 1/2 of the base times the height. So let's take this triangle right here, where I can easily see where the height would line up. So right here, there's my height, all right? Height, and then that would be my base at the bottom here, all right? And whenever you draw a height, it always comes down on the base at a right angle. So that's good, coming from the top here and coming down to the base, forming a right angle. And if you notice, it looks like we have something we recognize. We have this right triangle. And so if we are looking to figure out what the height is, but we happen to know that the hypotenuse is 2, and the whole base is 2, but from looking at just this triangle, the base is going to be 1. Let's go ahead and use Pythagorean theorem to figure out what my missing height is. So let's set that up. I've got a squared plus b squared equals c squared. And so I'm going to set up my a and my b and my c. I know that we were calling that h, right? But that will still be the b side of my triangle. I'll write base down here so it doesn't get confusing, all right? So that's gonna be the b side of my triangle. This guy's gonna be the a side of my triangle, and then always the hypotenuse opposite the right angle is gonna be my c side. So let's just go ahead, use the formula we have, plug in the numbers we've got, and see where we can go from there, all right? I've got 1 for a, so 1 squared, plus, b is unknown, so I'm gonna leave that as just b squared, because I don't know what it is, all right? And then I happen to know that the c, or the hypotenuse, is 2, so 2 squared. And now let's go ahead and simplify this. 1 squared is 1, plus, do not know b squared. So I'm gonna leave that on its own and solve for that later. 2 squared is 4. And so now I'm left with something I can further simplify. 1 plus b squared equals 4, all right? So now I'm gonna go minus 1 to get b squared on its own, because positive 1 is hanging out with b squared. B squared equals 3. Cool. So what we've found is that something times itself gives me 3. We have to figure out what that is. And if I want to undo b squared, I have to take the square root of that to get just b, which means I have to do it on the other side as well, algebra, all right? So b is going to equal the square root of 3, all right? So I guess I'll write root 3 here, all right? That's gonna be that height, all right? The b side. Let's find out what root 3 is. Got my handy dandy multiplication table here. And if I flip to the back of it, I'm gonna see my square root table. And I don't need all the way up to 225. All I need to know is the square root of 3, which is 1.73. Cool. So I guess what I'll do here is, for the sake of clarity, I'm going to kind of draw another height right here. But I'll write root 3 equals 1.73. All right? Cool. So that height is going to be 1.73, or root 3. And the base is going to be, for the whole triangle now, not just this half triangle, the whole triangle, 2. So let me go ahead, use my triangle formula, and let's figure out what the area of one of these triangles is. 1/2 of the base is now, again, remember, it's the whole triangle, so 2, times the height, root 3. All right, I'm gonna just put 1.73 though to make it easy, all right? So half of 2 is just 1 times 1.73 means that the area of each one of these triangles winds up just being root 3, or 1.73, 1.73, 1.73, again, how many of these triangles do I have? 1, 2, 3, 4, 5, 6. So let's just go ahead and let's do 1.73 times 6. 6 times 3 is 18. Carry the 1. 7 times 6 is going to be 42 plus 1, 43. Carry the 4. 6 times 1 is 6 plus 4 is 10. Move the decimal over 1, 2, 1, 2, and we have our area. The area of this hexagon right here is 10.38. I'm gonna continue looking at this for a second, but I'm gonna do that in the next video so that I don't take too much time on this one.